Hello everyone. Welcome to section 6.1. So this is the start of chapter 6, which is all about exponential and logarithmic functions. So we're going to start with this first section on composite functions because they're important when we talk about exponentials, but they also are more general ways where operational functions that apply to other kinds of functions. But this will lead us into specifically talking about exponentials and logs. So a definition, a composite function, and notation, right? So definition and notation. Given two functions f and g, the composite function is denoted by f with this little o and g, and it's read f of g. So f of g, that little o stands for f, and it basically means f composed with g, and it's defined like this. So f of g is f of g. So you read them the same way. Basically, to compose two functions, you plug one function into the other one and you simplify. So it's basically doing two functions in sequence, right? So a couple of things to note, right? One is that the order matters. So typically f of g is not equal to g of f, so it matters the way you do things. So this is not always, typically. Sometimes they are equal to each other, and if they are, they're special functions. We're going to talk about that in the next section. And the other note is about the domain. So the domain of the composition, the domain of f of g, is the set of all numbers x in the domain of g for which g of x is in the domain of f. So to find the domain of the composition, you first want to find the domain of g. Make sure you find any excluded values from the function g, and then you find the domain of the composition and you find the excluded value from that domain, and then you have to basically exclude all the values that you found, right? So let's see how to evaluate. Okay, so we want to answer for functions f of g, we want to figure out these values. Okay, so let's look at part A, where f of x is defined as 3x plus 2, like a linear function. G of x is 2x squared minus 1, a quadratic function. So we're asked to figure out f of g of 4. Right, so this is not multiplication, okay, in any sense. This 4 at the end means that you find the composition and you evaluate it at x equals 4. So don't multiply. But the best thing to do is look at the definition of it. So this means f of g of 4. So like with any operations, we have PEMDAS tells us to do the inside of the parentheses first. So this g of 4 gets done first. So first you do g of 4. So you plug in 4 into the g function. We get 2 times 4 squared minus 1. 2 times 16 is 32 minus 1, which is 31. Alright, so this replaces g of 4. Alright, so now we need to figure out f of 31. So this output here, you put in 4 into the function and get this output, and this gets plugged into the f function. All right, so you basically do it step by step from the inside out. Okay, so f of 31, you're going to take 31, you plug it into the f equation. 31 times 3 plus 2. 93 plus 2 gives you 95. All right, so this is the final result. So it's you're doing two sets of an equation in sequence. Sequence is important. You want to evaluate the inner function first to get a result and then take that into the outer function. And then 95, the final result, is the result of the sequence of operations. Okay? So you often see this like a sequence of function machines. Right, so we have the input, which in this case was 4. X is 4. Right, and we plug that into the G equation. Right, and then we get an output of 31. Now this becomes the input for my f function, whatever that is. You plug this into the equation, and then the final output is 95. Right, so basically you can think of it as a sequence of operation starting with the function that's innermost. And you can do this with more than 2 functions, 3, 4, 10, however, as long as you work from the inside out. All right, let's look at the next one. So we have our, oh, no, I think we need more here, okay? So we have g of f of 2. Okay, so let me do over here. I didn't leave myself much space, did I? So g of f of 2 means g of f of 2, so f goes on the inside. So we do f of 2 first, so the inner one first. Plug it into the equation. So we have 3 times 2 plus 2, which gives me 8. And then this gets plugged into the g function, g of 8. So we have 2 times 8 squared minus 1, 64. 128 minus 1 is 127. Okay, so this is the answer there. All right, so that was part B. This is part A. Let's look at part C. F of 1. F of 1. Rewrite it as f of 1. Do the inner part first. All right, so we need f of 1. This is 1 right here. So go to the f equation. 3 times 1 plus 2 gives me 5. This becomes the input. It replaces this, so you need to do f of 5. 3 times 5 plus 2, which gives us 15 plus 2 is 17. Right? Okay, let's do part D. G of 0. So g of 0, we're going to write it g of 0. Start with the inside of the parentheses. G of 0 equals, go to the g function, -1. Then take the -1 and replace it into here. So now I need g of -1, which is going to be 2 times -1 squared minus 1. 2 minus 1 equals 1. All right. Cool. All right, so let's do the same ones for these new functions. All right, so I need f of g of 4. That's part A. So f of g of 4. Okay, it's useful to write it this way. Once you get used to it, then you can you can see that the order you do them, you do 4 into g first, and then you plug in the result into the f. So you do the inner function and then the outer function. All right, so g of 4 is 1 minus 3 times 4 squared. 1 minus 3 times 16, 1 minus 48, which gives me -47. And so this gets replaced by -47. So we take f at -47, which is 2 times -47 squared. So we got to square 47, which I have no idea what it is, and then multiply by 2. Okay, so 247 squared gives me 4416. 4418. There we go. Alright, let's look at part B. So part B was g of f of 2. G of f of 2. This is the same as g of f of 2. Start with the inner f of 2. So plug 2 into the f equation. 2 times 2 squared. 2 times 4 is 8. And then replace the 8 into here. So g of 8 is going to be 1 minus 3 times 8 squared. 1 minus 3 times 64. 192. So this is negative 191. Alright, let's do C. Okay, C was f of 1. F of 1, which is f of 1. Start with the inner function. F of 1 equals 2 times 1 squared, which is 2. Then plug this into, replace the f of 1 here. So f of 2 now is going to be 2 times 2 squared. 2 times 4 is 8. As you can see, you can plug the functions into each other. The order very much matters. Actually, we didn't plug the same thing, but it does. The sequence is very important. Or you can plug a function into itself, because you might need to apply it twice. Okay, so let's do g of 0. So that means g of 0. We're going to find g of 0 first, which is 1 minus 0. Oops, it's a bit too soon. We don't want to box it yet because that's not the answer. And then replace the 1 into here. We find g of 1, which is 1 minus 3, which is negative 2. There we go. Alright, let's see what's next. Oh, we have a couple more like that. Alright, so let's do f of g of 4. Okay, so you plug 4 into g first. So g of 4 is going to be 12. Then we're going to plug 12 into f. F of 12 is going to be square root of 13. It doesn't simplify, so that's the final answer. Right. Let's do B. G of f of 2. Okay, so we do f into 2 into f first. F of 2 equals square root of 3. And then we plug that into g. So g of square root of 3 equals 3 square root of 3. Let's look at C, f of 1. Alright, so let's start to do backwards. Plug in 1 into f. F of 1 equals square root of 2. And then that square root of 2 gets plugged into f again. F of square root of 2 is square root of 2 plus 1. It looks kind of weird, square root inside of square root, but it happens. Alright, so D, g of 0. Alright, so 0 into g is going to be 0. And then 0 into g again, that's going to be 0 again. Alright, the more you do them, the easier it's apparent what you have to do at each step. So let's do it again with these two new functions. So f of g of 4. So plug 4 into g. G of 4 equals 2 over 5. Right, and then we're going to plug 2 over 5 into f. F over 2 over 5 equals 2 over 5 to the 3 halves. Right, and you can leave it like this. I don't think you can simplify. You can rewrite it, but I don't think it's any better. Right, g of f of 2. Okay, so we're going to plug 2 into f. F of 2 equals 2 to the 3 halves. And then we're going to plug this into g. So g 2 to the 3 halves equals 2 over 2 to the 3 halves plus 1. Right. Let's do c. F of 1. So f of 1 first. 1 to the 3 halves, which is 1. And then we're going to plug that into f again, and we get 1 again. F of 1 equals 1. Right, part D, g of 0. So let's find g of 0, which is 2 over 1. And then we're going to plug 2 into g again, g of 2, we get 2 over 3. All right, cool. Okay, so let's look at doing function composition in general. So we're not giving a value to plug in, we're just plugging one function into the other, and then we want to state the domain. Okay, so let's do part A. We want to find f of g. Okay, so basically this means you have f of g of x. So you're plugging g in the f function. All right, so basically whenever you plug in a value, you are replacing x everywhere you see with that value. So this x right here is going to be replaced by g of x. So we have f of x, not f of x, f of g of x. So let's get rid of this. So this is going to be, instead of x, we write g of x plus 1. Right? And to simplify it, you're going to replace, g of x gets replaced by its equation. So x squared plus 4 is the g part, plus 1. We get x squared plus 5. All right. So now let's look at the domain. Okay, so the domain you want to look at the domain of the inner function. Okay, so first we need to look at the domain of g of x. So this is a polynomial, which means the domain, there's no excluded values. The domain is all real numbers from negative infinity to infinity. Okay. And we then look at the domain of the result. So we need to look at the domain of f of g of x. This is also a polynomial function, so the domain is from negative infinity to infinity. Okay, so the domain of the result is negative infinity to infinity. If you had different domains, then you have to piece it together to make sure that whatever is excluded from both of them, both of the pieces, will be excluded together from the domain of your result. Let's do part B. G of f of x is g of f of x. I'm going to plug f into g. Alright, so you go to your g, you see that it's x squared plus 4. well, the x part gets replaced by f of x. Okay, so this is going to be f of x squared plus 4. And now we're going to put in what f of x is. X plus 1 squared plus 4. Okay? And you can expand it out. X squared plus 2x plus 1 plus 4, which is x squared plus 2x plus 5. Alright. Now the domain, because both the inside function f of x is a polynomial and the result is a polynomial, then the domain is going to be all real numbers. Okay, there's nothing that needs to be excluded because you're either dividing by 0 or because they're square roots. Right, let's look at f of f. So f of x. All right, so this, you go to your f function, which is x plus 1, and you replace the x by f of x. So you have f of x plus 1. Now you replace f of x by its definition, which is x plus 1, and then plus 1, which is x plus 2. Okay, so that's composing a function with itself. Okay. And the domain, because everything is polynomials, the inner function and the result, it's all real numbers. Let's look at D. G of G, we're plugging G inside G. I don't need that many parentheses. Alright, so G of X is going to replace any x's in the G function. So we have x squared become G of x squared plus 4. Replace this G of x with its equation. So x squared plus 4 squared plus 4. Expand it out, we have x squared plus 8x, x to the 4 plus 8x squared plus 16 plus 4, which is x to the 4 plus 8x squared plus 20. So that's the composition. For the domain, because the inner function and the result are both polynomials, the domain is going to be all real numbers. Okay. Again, you don't worry unless you get fractions or radical or square roots in there. Alright, there's one with fractions. Okay, so we can look at composing these. Okay, so we've asked the same questions. Let's find f of g of x. So we look at our f function, and the x part gets replaced by g. So g of x plus 3. Then write what g is. So 1 over negative 2 over x plus 3. We got to simplify this. Okay, so find common denominator, 1 over negative 2 plus 3x over x, and do the reciprocal, so x over 3x minus 2. Okay, so this is the composition. That's f of g. Alright, let's look at domains. Okay, so first we need the domain of the inner function. Okay, so if I look at g, you can see that it's all the real numbers excluding x. So it's all the reals, but excluding x is 0. Right? And we look at the domain of this. So we have x over 3x minus 2. And this is all the real numbers excluding when this is 0, which is 2 over 3. So the combined domain for the composition is going to be the real numbers minus both of these. So minus 0 and 2/3. Right? And you can also write this in interval negative infinity to 0, 0 to 2/3, and 2/3 to infinity. All right, so here's as an example where you get excluded values. All right, let's look at part B. G of f. So g of f of x. Okay, so you start with g function is 2 over x, but the x gets replaced by f of x. So this gives me negative 2 over whatever f of x is, 1 over x plus 3. And we simplify. Okay, so this is going to be negative 2 times x plus 3, or negative 2x minus 6. Okay, so this is the result of the composition. All right, domain. All right, so the domain, you have to look at the inner function first. So let's look at f of x, which is 1 over x plus 3. So you can see the domain is everything, all the reals except for x is negative 3. Now we need to look at the domain of the result. Okay, so g of f of x is negative 2x minus 6. There's nothing that's excluded, so this is all the real numbers. All right, so we look at the combined domains. It's like we have these. We want to make sure that everything that's excluded from either of these is excluded. So the final domain is going to be the real numbers. You got to make sure that negative 3 is excluded. Okay, so nothing was excluded from the result, but negative 3 was excluded from the inside function, so that needs to be excluded at the end. All right, let's look at C. All right, C was f of f. So f of f, we have f plugged into f. Okay, so we have 1 over x plus 3. So the x gets replaced by f of x. So we have 1 over the equation of f, which is 1 over x plus 3, plus 3. All right, we gotta simplify this, find common denominator. Then we get 1 over 1 plus 3 times this, 3x plus 9 over x plus 3. Do the reciprocal, so this is x plus 3 over 3x plus 10. Right, so this is f of f. All right, domain. So domains. All right, the domain of the inner function. All right, if I look at f, 1 over x plus 3, then it's the reals excluding negative 3. All right, and the domain of the result is going to be all the real numbers excluding negative 10 over 3. So the combined domain is going to be all the real numbers excluding negative 3 and negative 10 over 3. So two values where things are going when we're dividing by 0. All right, I'm not going to do g of g because I don't have room. All right, okay, so here's one more. All right. Same deal. Find the compositions and then state the domains. And this time with radicals. Okay, so let's do it with that. Okay, so part A, we're doing f of g. So we're plugging g into f. So f is square root of x minus 2. So the x gets replaced by g of x. All right, so we get square root of g is 1 minus 2x. And then minus 2. We're going to simplify. We have negative 2x minus 1. Alright, so this is the result. We're going to look at the domain. Alright, so the inner function, okay, so if I look at the domain of this is all real numbers because it's a polynomial. If I look here, the domain of this, we need, because of the radical, this needs to be positive. So we need 2x minus 1 to be bigger than or equal to 0. Which means negative 2x is bigger than or equal to 1, x is less than or equal to negative 1/2. Alright, so the resulting domain, it needs to work for both the inner function and for the result. So we need to make sure that x is less than or equal to negative 1/2. And let's look at part B. G of f. So we're plugging f into the g function. So we have 1 minus 2 times x. So the x gets replaced by f of x. And that's it. We can't really simplify it. All right, let's see the domain. So my inner function is f. And the domain, there's a radical there. We need x minus 2 to be bigger than or equal to 0. So x needs to be bigger than 2. Now for the result, we have a radical. Still, we need x to be bigger than or equal to 2. So they both have the same condition. Okay, so the resulting domain is that x has to be bigger than or equal to 2. Okay, let's look at C. F of f. So f of x. Okay, so we take the f function, which is square root of x minus 2. X gets replaced by f of x. So this is going to be the square root of x minus 2 minus 2. Okay, cool. So this is our composite function. Let's look at the domain. So the inner function is f of x. We need x to be bigger than or equal to 2. Our result, so we need this thing inside the radical, x minus 2 minus 2, to be bigger than or equal to 0. So x minus 2 has to be bigger than or equal to 2, which is x minus 2 has to be bigger than or equal to 4, square both sides. So x has to be bigger than or equal to 6. Alright, so we have these two restrictions. We want to make sure that our combined domain is going to restrict all the values that are not possible in either of these. Alright, so the more restrictive one is this one. Okay, so we need x to be bigger than or equal to 6. Okay, because if we have anything that's smaller than 6, it's not going to work for this. Okay, if we have everything bigger than 6, it's going to work for both. Right, let's look at D. G of G. So we need to plug G into G. Alright, so 1 minus 2 times x, that gets replaced by G of x. So it's 1 minus 2 times 1 minus 2x. 1 minus 2 plus 4x, which is 4x minus 1. Alright, so the domain. So the inner function is g of x, which is a polynomial. The result is a polynomial, so the domain is all real numbers. Okay, no restrictions. let's look at one more. Another one with radicals. So f of g is f of g of x. So we have our f function, x squared plus 4. Alright, so the x gets replaced by g, which is square root of x minus 2. And we square that and we add 4. Okay, so let's simplify. Square cancels out the square root. We get x minus 2 plus 4, which is x plus 2. Alright, domain. First, let's look at the inner function, which is g. Alright, the domain of this needs to be positive, so x has to be bigger than or equal to 2. The domain of the result is all real numbers, because it's a polynomial. So you can compare these, so you need the more restrictive ones to make sure that they both work. So we need x is bigger than or equal to 2. Alright. Part B. G of f of x. So we start with a g function, and we need to replace the x in here by f of x, which is going to be x squared plus 4. Okay, so it's equal square root of x squared plus 4 minus 2. So square root of x squared plus 2. Alright, domains. So inner function here is f of x, which is a polynomial, so the domain is all real numbers. The result is square root of x squared plus 2. We need this x squared plus 2 to be positive, which automatically it is. Right, because you have something that's squared and you're adding 2 to it, so this works. So this is also all real numbers. Right, so the domain of this is going to be all real numbers. Right, let's look at C. F of f. Okay, so we have x squared plus 4. Okay, so the x gets replaced by f of x. Right, now replace the f, which is x squared plus 4. And then everything should be the same. So we have x to the 4 plus 8x squared plus 16 plus 4. So this is my result. Alright, domains. So the original one is f of x, which is a polynomial, so domain is all real numbers. The composition is a polynomial, so this is all real numbers. So the resulting domain is all real numbers. Alright, let's do g of x. So we have square root of g of x minus 2. G of x is square root of x minus 2. Like this, inside a square root minus 2. Okay, so this is the composition here. Alright, so the domain. The inner function is g of x, which is square root of x minus 2. This needs to be positive, so x has to be bigger than or equal to 2. Alright, so there's some restrictions there. And now we need to look at here. So the inside of this big square root needs to be bigger than or equal to 0. So square root of x minus 2 is bigger than or equal to 2. Square both sides. X minus 2 is bigger than or equal to 4, so x is bigger than or equal to 6. Alright? Alright, so the more restrictive one is this one. So the domain is going to be x is bigger than or equal to 6. Okay, let's look at this next example. So we learned how to do the composition of two functions, but really useful thing to know is how to decompose them. So basically, and this is not unique. You can do them in more than one ways. So we're given h of x, which is the composition of f of g, and we need to break them apart to figure out what f and g are. Okay? So basically, g is the inner function, and f is the outer function. So what you want to do is you want to find things that are in parentheses most of the time, or under square roots, or at the bottom of a fraction. Those are all its good g of x's, and call that g of x. Okay? So I'm going to call this g of x. And again, this is not unique. Sometimes it is, but we're going to say g of x is 1 plus x squared. Okay? So then, h of x equals g of x cubed. Okay? To find f of x, you're going to replace g of x by x. Right? So basically, we're doing things backwards. So f of x is going to be x cubed. Right? So this is my pair of functions. G is 1 plus x squared, and f is x cubed. Right? So you can see that if I compose them, right, if I find f of g, we take the f function, which is x cubed, and replace the x by the g function, and we end up with what we started with. Okay, so these ones you can always easily check. All right, part B, let's do the same thing. So I have square root of something, so let's call this inside of the radical, let's call that g. That's the inner function. Let's rewrite h. So h of x is going to be the square root of g of x. Right, then we're going to call g of x, replace g of x by x. So f of x is going to be the square root of x. Okay, so this is my definition. G of x is 1 minus x squared, which gets plugged into f of x equals square root of x to compose and give us our h of x. Alright, that's it for this section. Have fun watching the video for it.